Get ready for a game tug of war. So here we have a tug of war between Mr. Bulldog and Mr. Mouse. Who's going to win? Mr. Bulldog is stronger, bigger. He's going to win. Is there any way to tie it up? I think there is. Supposing if we had a whole bunch of mice, then they should be able to pull just as strong as Mr. Bulldog. In other words, a whole bunch of little guys equals a big guy. Alright, so supposing if we had a tug of war between Mr. Meter and Mr. Picometer. Well, we know that one picometer is going to be equal to 10 to the minus 12 meters. So, who would win that tug of war? Looks like Mr. Meter would win easily. But how could we tie it up? Couldn't we put a whole bunch of little guys equaling a big guy? In other words, since a picometer is 10 to the minus 12 meters, 1/trillionth of a meter, what if we had 1,000,000,000,000 picometers, and that would be equal to a meter? Let's try the tug of war game some more. Supposing if we have, for instance, 1 micrometer, and we know that that's equal to 10 to the minus 6 meters. Tug of war, whole bunch of little guys, 10 to the minus 10 to the 6 micrometers is going to be equal to 1 meter. A few more tries. Now for the powers of 10, which are already greater than 1, the tug of war is already set up for you. So for instance, a kilometer is equal to 10 to the third meters. A big guy is equal to a whole bunch of little guys. A megameter would be equal to 10 to the 6 meters. Again, a big guy is equal to a whole bunch of little guys. When we have a power of 10 which is less than 1, for instance, a nanometer is equal to 10 to the minus 9th meters. Then we play we don't have to, but we can play the game of a whole bunch of little guys is going to be equal to a big guy. Supposing if you were to compare something like a centimeter to a kilometer. I'm going to show you a way to do that. We're going to diagram it out. Once you know your metric prefixes really well, what I'm doing in the diagram you can do in your mind's eye. So let's make a number line, and we're going to have the root unit here is meter, and that's going to be 10 to the 0. A kilometer is 10 to the third. A centimeter is 10 to the minus 2. So my question is, going from 10 to the minus 2 to 10 to the third, how many powers of 10 is that? We always want to express it as a positive power of 10, so that is 10 to the fifth. Yeah. Next question, who's the little guy? Who's the big guy? Centimeter is the little guy, and therefore we can say that a whole bunch of little guys is going to be equal to a big guy. Now we're going to compare a microsecond to a femtosecond. Let's make a number line. Again, pretty soon you can just do this in your mind's eye. So the root unit here is going to be second, which is 10 to the 0. The microsecond is 10 to the minus 6, and the femtosecond is 10 to the minus 15th. From 10 to the minus 15th to 10 to the minus 6, how many powers of 10 do we have? 10 to the 9th. And again, I always want to express it as a positive power of 10. Finally, who's the little guy? The little guy would be femtosecond. So what we have are a whole bunch of little guys, 10 to the 9th femtoseconds equals one big guy, 1 microsecond. Final example, let's compare something like a milligram to a nanogram. Number line, root unit here is the gram, which is 10 to the 0. Milligram is 10 to the minus 3. Nanogram is going to be 10 to the minus 9. There are a factor of 10 to the 6 between those. Nanogram's the little guy, and we have a whole bunch of little guys equals a big guy.